Hello there, this is brilliantmaths.com, where every student has an opportunity to learn and excel in maths. Subscribe to brilliantmaths.com. We have lots and lots of resources for you. We have workbooks that cover primary school mathematics. We have modules that cover secondary school maths. Today's lesson is actually taken from Brilliant Maths Module 7. So get a copy and let's go to class. In this lesson, we are going to be looking at circle theorems. Circle theorems is actually a very interesting topic. All you need to do is be alert. Look out for the facts that you'll be given. The first theorem we're looking at today is angle in a semicircle. And the theorem says that the angle subtended by the diameter at the circumference is a right angle. The angle subtended by the diameter at the circumference is a right angle. So first, what do we mean by subtend? What does it mean for an angle to be subtended by the diameter or by an arc? So for example, we have a circle and we have an angle at C, and we have arc AB subtends the angle at C. It means that the arc AB is actually what forms the angle at C. So arc AB subtends the angle at C. C is at the circumference. So with this theorem, it says the angle subtended by the diameter. That means the diameter is what forms the angle. That's what we have here. The angle subtended by the diameter at the circumference is a right angle. So we're going to be working with that theorem. But before we continue, let us look at some of the vocabulary we'll be meeting. Circumference, we know that already. The circumference of a circle is the outer boundary, the distance around it. That's the circumference. Then the diameter. The diameter divides the circle into two equal parts. It passes through the center from one end of the circumference to the other. And then we have the radius. The radius is half of the diameter. It's from the center to the circumference. And when you have two radius, it is called radii. Radii is the plural of radius. The center of the circle is very important when you are learning circle theorems, because a lot of the theorems have to do with the center. So that's the center of the circle there. And when you have two radii enclosing a portion, it is called a sector. That's the minor sector, because the portion enclosed by these two radii is smaller than the rest of the portion. So we have the minor sector, and then the rest of the portion is the major sector. That's the place dotted within the circle. So we have the minor sector and then the major sector in the circle. Then we have a chord. A chord is a line from one part of the circumference to another, but does not pass through the center. So that's the chord. The chord divides the circle into two. A minor segment, which is a smaller part, and then a major segment. So within this circle, we have separated the sector and the segment. You just need to be careful and understand it. So the chord separates the minor segment from the major segment. Then two radii separates the minor sector from the major sector. That's the vocabulary we will need for circle theorems. So let's work out an example that is related to this theorem. The angle subtended by the diameter at the circumference is a right angle. So that's our diameter. anytime you're working with the center, it will usually be indicated. So that's the center. And that's the diameter. So the theorem says that this angle that is formed by the diameter at the circumference is a right angle. And then we are supposed to find angle x. So the question says, find the size of angle x. That's a triangle, and the sum of the angles of a triangle is equal to 180 degrees. So if we know that this angle is 90, that means that the sum of the other two angles, if I have this, plus x, will also be 90. So that 90 plus 90 will give us 180 degrees. But we have an outer angle there, which is given as 102 degrees. So we can find angle ACB first, before we find x. ACB is on a straight line with angle 102 degrees. So to find the angle at C, we simply subtract 102 degrees from 180 degrees. So the angle at C, angle ACB, is 180 degrees minus 102 degrees, which gives us 78 degrees. So this angle is 78 degrees. And now when we have this angle, we can simply find our x. What is the value of angle x? X will then be 90 minus 78. It's easier to do that than to add 90 to 78 and subtract from 180. You'll still get the same answer, and I choose the easier one. So angle x, which is equal to angle ABC, is 90 degrees minus 78 degrees, and that gives us 12 degrees. Like I said, circle theorems is actually very easy. Let's look at another theorem. In this part of the lesson, we want to look at angle at the center. The next theorem says the angle subtended at the center is twice the angle at the circumference if both angles are subtended by the same arc. I want us to be able to identify the arc that subtends an angle. So let's look at this drawing. We have the arc AB. As we can see, the arc AB forms the angle 2x at O. That means the arc AB subtends the angle 2x at the center. So the theorem is saying that any other angle subtended by AB at the circumference will be half that at the center. So that means that the angle at the circumference is twice that at the center, as long as they are subtended by the same arc. So arc AB subtends 2x at the center O, and arc AB subtends the angle S at the circumference. So the angle at the circumference is x, and then the angle at the center is twice x, which is 2x. So AOB is equal to 2ACB. Very easy. Then we look at the next diagram we have here. We have the arc PQ. The arc PQ subtends angle A at the center. And then we know that the arc PQ also subtends angle 43 at the circumference. So what is the value of A? You can actually do this mentally without any much calculations. If this angle is 43 and it's at the circumference and is subtended by the same arc, but this time the other angle is subtended at the center, that means that the angle A is equal to twice 43. So A is equal to 2 times 43 degrees. So the angle at the center is equal to 86 degrees. That takes us to the next diagram. this looks a little bit more complicated. The concept here is to find the major sector and the minor sector. So for example, in this diagram, PQ, this part of PQ is a minor sector. So it subtends the angle A at the center. But the major sector, PQ major, will subtend another angle here, which will be 360 minus A, still at the center. So with that concept, we have arc MN. Arc MN, the minor arc MN, subtends the angle B at the center. You can see that it forms that angle B at the center. And then the minor arc MN subtends another angle at the circumference. So that angle is going to be half B because it's at the circumference. The one at the center is twice that at the circumference. I wanted to use that half concept. The major arc MN subtends angle X at the circumference. Major arc MN subtends S at the circumference. And then subtends another angle at the center. This major arc, it forms 2x at the center. So just take note, look out for the particular arc that subtends any given angle. And finally, let's look at this diagram. We have the triangle ABC and triangle ABO. And we are given this angle at B to be 50 degrees. Angle ABO is equal to 50 degrees. Then we're asked to find BCA. How do we find that? We know that the angle C, or the angle at C, is supposed to be half of the angle at O, because angle C and O are subtended by the same arc. As you can see, the arc AB subtends that angle at the circumference, and the same arc AB subtends the angle at the center. But we don't have the angle at the center. However, we have one of the base angles. How do we find this angle at the center? Knowing that OB and OA are both radii, that means we have an isosceles triangle in here. So this angle is also 50 degrees. Going by that. So if that angle is 50 degrees, that means the angle at the center is 180 degrees minus 100, because the sum of the angles of a triangle is equal to 180 degrees. So 180 minus 100 gives us 80 degrees. So the angle AOB at the center is equal to 80 degrees. So if that angle is 80, what is the value of angle BCA? The angle at the center is twice, because they are subtended by the same arc. Half of 80. See how easy it is. So we can complete that. BCA is equal to 40 degrees. Anytime that you are working circle theorem problems, look out for the particular arc that subtends any given angle. That will help you solve the problems. Let us look at another example. We're still looking at circle theorems and precisely the angle at the center. The angle subtended at the center is twice the angle at the circumference if both angles are subtended by the same arc. During the last lesson, we were able to discover how to find the arc that subtends any given angle. So for this example, it says, given that O marks the center, so O marks the center of the circle, calculate the size of the marked angles. So we have the size of angle X and Y to calculate. Let's see how we can find that. We were only given an angle here, which is 150 degrees. So let's find the arc that subtends that angle. So we go from the angle across to the circumference. So we can see that the major arc AC subtends the angle 150 at the circumference. The angle at the center that major arc AC subtends is not given, but we can determine that angle. So this angle, which is not given, is equal to twice the angle at the circumference, 150. So this major angle here will be equal to 150 times 2, which is 300. So if we know that that angle is 300, then angle Y is equal to 360 minus 300. So Y is equal to 360 degrees minus 300 degrees, which is equal to 60 degrees. So angle Y is 60 degrees. The minor arc AC subtends angle Y at the center. And the same minor arc AC subtends angle X at the circumference. So if we know that Y is equal to 60 degrees, then angle X is equal to 60 degrees divided by 2, or half of 60 degrees, because Y is at the center and X is at the circumference, and both of them are subtended by the same arc. So X is equal to 30 degrees. For detailed workout of this example, get a copy of Brilliant Maths Module 7. In this part of the lesson, we want to look at angles in the same segment. What does the theorem concerning angles in the same segment say? It says angles subtended by the same arc in the same segment are equal. Very easy theorem. If the angles are subtended by the same arc and they are in the same segment on the circumference, they are equal. So we have an example of angles in the same segment. So what do we mean by same segment? So assuming that's a chord. So this will be the minor segment, and then that will be the major segment. But remember, AB is the arc subtending C, D, and E at the circumference. But this is our center. So also relate that. The angle subtended at the center is twice that at the circumference if they are all subtended by the same arc. So assuming this is X, that also means the angle at D is X, and the angle at E is X. Y, arc AB subtends X at E. The same arc AB subtends that angle at D. And the same arc subtends the angle X at C. So they are all equal. And the same arc subtends the angle at the center, O. What will be the value of that angle? The angle at the center will be twice. So take note of that. Then we have an example. We have that circle. O is the center of the circle. And we have an angle A at the circumference. Angle 35 at the circumference. So what we need to find out first is which arc subtends the angle A. So let's try to label this arc PQ. All right, everything meets there. PQ. O is the center. Anytime you have a center, it is usually indicated. So O is the center. And then arc PQ subtends the angle 35. You can see that that's what forms it. And the same arc PQ subtends the angle A at the circumference. So what does that tell you? The same arc subtends angle B at the center. So let's see, what does the question say? O is the center of the circle. We have seen that already. Find the value of angle A and the value of angle B. So we said that A and 35 are subtended by the same arc. Angle A is equal to 35 degrees. What is the reason? Angles subtended by the same arc in the same segment. So the same arc subtends angle 35 degrees and angle A. Therefore, A is equal to 35 degrees. Then angle B. What is B equal to? Angle B will be equal to 35 degrees times 2 because the same arc subtends B at the center and 35 at the circumference. So B is equal to 35 degrees times 2, which is equal to 70 degrees. And then give us the reason. The reason is angle subtended at the center. So whenever you work with circle theorems, you'll have to give the reason or how you get the solutions that you get. So A is equal to 35 because angle 35 and angle A are subtended by the same arc and then the same segment. That's the segment there. And then the angle B at the center is equal to 70 degrees because the angle at the center is twice that at the circumference. They are both subtended by the same arc. To get more practice, get a copy of Brilliant Maths Module 7. In this part of the lesson, we want to look at circle theorems that are related to cyclic quadrilaterals. What is a cyclic quadrilateral? A cyclic quadrilateral is a four-sided figure inside a circle, within a circle, such that the four vertices of the quadrilateral are on the circumference of the circle. If any of the vertex is not on it, it is not a cyclic quadrilateral. For it to be a cyclic quadrilateral, all four vertices must be on the circumference of the circle. So the theorem states that the sum of the opposite angles of a cyclic quadrilateral is equal to 180 degrees. This is a very easy theorem to understand. So we have a cyclic quadrilateral, PSRQ or PQRS. And then the angles within them, the opposite angles, are supplementary. The opposite angles add up to 180 degrees. That means that A plus C will give us 180 degrees. And B plus D will give us 180 degrees. Then let's look at angle E. B and E are on a straight line. So that also means that B plus E will give us 180 degrees. So that implies that angle E is equal to angle D. So that gives us another rule that says that the exterior angle of a cyclic quadrilateral is equal to the interior opposite. The exterior angle, which is E, is equal to the interior opposite, which is D. So angle D is equal to angle E. Let's look at this example. Find the value of X and Y. So the first step is check if it's a cyclic quadrilateral, and it is, because all the vertices are on the circumference of the circle. So next is to find the opposite angles. Which angle is opposite to which? X and 82 are opposite, so both of them should give us 180 degrees. So x plus 82 degrees is equal to 180 degrees. So x is 180 degrees minus 82 degrees. 10 take away 2 will give us 8. And then we have a 7 there. So 17 take away 8 will give us 9. So that means that x is 98 degrees. 98 plus 82 is equal to 180 degrees. So that's good. Next, we're supposed to find y. We have found x. So y is equal to, we know that 2y plus y will give us 180 degrees. So we start off with that. Y plus 2y is equal to 180 degrees. So 3y is 180 degrees. So y is 180 degrees divided by 3, which is 60 degrees. So it's very easy. Just make sure that you find out if it is actually a cyclic quadrilateral before you start. And for it to be a cyclic quadrilateral, the vertices of the quadrilateral must lie on the circumference of the circle. For more exercises and examples, get a copy of Brilliant Maths Module 7. In this lesson, we want to look at tangents to circles, still working with circle theorems. A tangent to a circle is perpendicular to the radius drawn to the point of contact. But what do we mean by a tangent? A tangent is a straight line drawn that touches a circle at a particular point, and that point is called a point of contact. So for example, we have this circle, and AB is a tangent, and it touches, the line AB touches the circle at point X, so that the theorem says that AXO, the angle, is 90 degrees. That's what we mean by perpendicular. So a tangent to a circle is perpendicular to the radius drawn to the point of contact. So you draw the radius to the point of contact with a tangent, and the angle there is 90 degrees. So knowing that, we have a circle with center O, and we have two tangents drawn. So the first tangent is BC, and then we have another tangent, AC, and the two tangents meet at C. Looking at this diagram, we know that the radius of the circle is OA and OB, so they are equal because they are both radii. The radius makes 90 degrees with the tangent at the point of contact. So this angle is 90, and also the angle at B here is also 90 degrees based on this rule. We want to work out an example with this, knowing these facts. So example, it says TA and TB are tangents to the circle with center O. So we have TA, that's a tangent, and we have TB, another tangent. The center of the circle is O. And the angle where the two tangents meet is 50 degrees. That's angle ATB is 50. Then the question is, find ABT. ABT. That is the angle we have here. And also find OBA. OBA. And that's the angle we have here. So that's the task. we have all the information we need to be able to find those angles. Remember that triangle TBA is an isosceles triangle because we have established that AC here is equal to BC. So that means that TA is equal to TB. So if TA is equal to TB, then we have an isosceles triangle. So if that angle is 50, then the angle ABT will be half of 180 minus 50. So you subtract 50 from 180, which is the sum of the three angles, and you have 130 degrees. So half of 130 degrees is 65 degrees. So that angle is 65 degrees, and the other angle is also 65 degrees, since it's an isosceles triangle. Look at how easy it is. You look at the diagram and you think that it is difficult, but it is not. Just take it step by step. So we have found angle ABT. ABT is 65 degrees. The next question is find angle OBA. How do we find angle OBA? OBA. So that is the angle in the triangle here. We know that OBT is 90 degrees, tangent and radius. The radius and the tangent, so it makes 90 degrees. And we know that TBA is 65. So if this is 65 and the entire angle is 90, that means that our OBA, therefore OBA, is equal to 90 degrees minus 65 degrees. And 90 degrees minus 65 degrees will be equal to what? That will give us 25 degrees. So angle OBA is equal to 25 degrees. For more exercises and more examples, get a copy of Brilliant Maths Module 7. This is our 6th or 7th lesson on circle theorems. If you haven't seen the others, go get the videos. Angle between a tangent and a chord. The theorem says that the angle between a chord and a tangent at one end of the chord is equal to the angle the chord subtends at the circumference in the alternative segment. What does that even mean? The angle between a chord and a tangent. So we have our diagram here. This is a circle. This is a chord of a circle called AB. And the angle theta is the angle between the chord and the tangent. All right? So that angle is equal to the angle the chord subtends. So the chord AB subtends the angle theta in the alternative segment. So theta is in this segment, but the chord subtends theta in the alternative segment. So they are equal. That's all that the theorem is saying. That the angle between the chord and the tangent is equal to the angle that the same chord subtends at the alternative segment. Let's look at an interesting example. PQR is a tangent to the circle at Q. So that's the tangent, that's the circle. That means that the tangent touches the circle at Q. All right. Angle YQR is 54. YQR. So that's the angle between the chord QY, and the tangent QR. So the angle between them is 54. And from the theorem, we know that that angle is equal to the angle that the chord subtends at the alternative segment. So this angle will also be equal to 54. I'm just adding that before I finish reading the question. It says, find the size of XQY. XQY. So we're finding the size of this angle. And that is quite easy to find because we know that angle xy is 54. And once we know that that angle is 54, we add both of them and subtract from 180. So solution, angle Q. So solution, angle XQY plus XYQ plus QXY. Those are just the three angles in the triangle, will give us 180 degrees. Then we know that QYX is 41 degrees and XQY is what we are finding. So QXY is 54 degrees by the theorem. So going by that theorem, that is 54. So XQY is equal to 180 degrees minus the sum of 54 plus 41 degrees, and that gives us 85 degrees. For more examples, get a copy of Brilliant Maths Module 7, and we can see and take note that angle QSY, angle QXY is equal to angle YQR, going by this theorem. Some other people call it alternative segment theorem. Get a copy of Brilliant Maths Module 7 and get more examples and exercises. I hope you enjoyed those lessons on circle theorems. We looked at all the theorems related to circles. You really have to watch those videos. Get a copy of Brilliant Maths Module 7. Subscribe to brilliantmaths.com and follow us on all our social media handles, and you will be on your way to success in maths. My name is Ngozi Orevogene, and always remember that maths is fun and you can excel in it.